New R2D2 robot upgrades, part 2, using ChatGDP plus AI and a new MCU. Upgrade the Raspberry Pi MCU from a Raspberry Pi 2 to a Raspberry Pi 4 on the large R2D2 robot. Upgrade the VEX EDR microcontroller to a newer VEX Cortex plus VEX Cortex game controller. Item 3. Mount the new controllers on Raspberry Pi 4 and the VEX Cortex inside the body of the R2D2 so it looks much neater. Item 3.5. Make it look neater. Uses an Arduino NICLA for TinyML and AI voice recognition. Item 4. Reuse all the free basic code that I coded for the Hero 1 robot application. Item 5. Demonstrate the Robot Basic Simulator using the TCP/IP link, Wi-Fi, and USB serial cable using debug stream from the VEX Cortex Robot C. Item 6. Add new sensors to the R2D2. Include the Arduino Nano BLE33 Sense board, which will provide an XYZ accelerometer, a gyro, a temperature sensor, a pressure sensor, and a humidity sensor, as well as a microphone. Item 7. Use the Raspberry Pi camera for teleoperated control of the R2D2 robot. And the camera can be placed in the head as well as the Raspberry Pi 4 can be put in the head of the robot. There's enough room in there. Figure 1 block diagram. In the figure you see the Raspberry Pi 4 MCU and you see the VEX EDR game controller box. The Arduino NICLA voice recognition module is connected to the Raspberry Pi 4 using a USB port. The VEX EDR Cortex MCU is connected to the Raspberry Pi 4 using two USB ports that are connected using USB serial cables to the UART1 and UART2 on the VEX EDR Cortex MCU. And they work at 115/200 baud serial RS-232 protocol. We also have a block for the Arduino Nano BLE33 Sense, which includes the digital compass, the gyro, the temperature, pressure, and humidity sensors, as well as a microphone. The VEX EDR MCU is responsible for controlling the left motor, the right motor, and the head motor on the R2D2 robot. It has all the built-in drivers necessary for it using the motor port. And it can also input up to 12 digital IOs, including 4 limit switches, which will act as bumper switches for the R2D2. They will be glued near the bottom of the wheel wells, so that if the robot hits any object or person or wall or animal, it'll immediately stop for about 15 seconds. And then it can resume control using the VEX EDR game controller. New features. The Raspberry Pi 4 can run advanced control algorithms in Python 3 and FreeBasic. It can use ChatGDP prompting using its Wi-Fi connection. It also uses Raspberry Pi Connect to allow you to teleoperate the R2D2 robot, and it'll be able to see what the camera sees and transmit the real-time video back to a PC or laptop, or even a phone. For communication between the PC, laptop, and the robot. It uses a Raspberry Pi camera for fast response for teleoperated operation. For fast response from the VEX Cortex to move the motors, read sensors, and uses the game controller. It also can support analog joysticks for motion input using the 8 analog inputs that the Raspberry Pi, the VEX Cortex has. Navigation, the Arduino Nano BLE Sense board has navigational sensors, including a gyro, a magnetometer / digital compass, XYZ accelerometers to measure tilts, and it also has environmental sensors, including a temperature sensor, humidity sensor, and a pressure sensor. And it even has a microphone, so it can input sounds and even voice commands. It can read the temperature, pressure, and humidity, and then transmit it back to the Raspberry Pi using a USB to serial cable or using Bluetooth with the Raspberry Pi. The Bluetooth BLE works very well. I can reuse the Bluetooth code from my weather station application. TinyML plus AI on the Arduino Nicola. The Arduino Nicola is a very advanced board that allows you to do TinyML and AI applications